Welcome back, everyone. Today, we'll see how to add database access to our web app. We'll do that with SQL Alchemy. We'll also look at the syntax of Jinja 2 and see how we can use it in our HTML templates. So here's what our web app looks like so far. We have our Flask app program. Here we define the routes that link each URL to a function, and in the main function, we just run the server. We saw that it's convenient to run the server in debug mode so that the changes are picked up as we make them without having to stop the server and restart it. We are using two templates here. Our home template that is rendered here in the browser, and our about template, and here's how it's rendered. At this point, our templates just look like regular HTML documents and they're rendered in the browser. Now on the home page, one of the links we have is a review link. We would like users to be able to add reviews for CS122. So we need a database to store these reviews. We'll use a relational database to do so. In a relational database, data is organized in one or more tables with a unique key identifying each row. Each table represents one entity type. For example, we can have a table for students and another table for courses. The rows represent instances of that type of entity. For example, in the students table, we could have Alex and Claire. In the courses table, we could have CS122 and CS156. The columns represent values attributed to that instance. In the students table, we could have an ID column, maybe a major column. In the courses table, we could have a description column, a number of units column. Now, different SQL databases implement SQL with slight variations. They have different ways of passing parameters into queries. The same SQL statements may not work across different databases. So because of that, including SQL statements in our Python code would make our code less maintainable. If we were to switch databases, we would have to go back and change our program. The solution is to use an Object Relational Mapper, ORM for short. The Object Relational Mapper maps relational database types and structures to Python objects. There are several open source ORMs available for Python. There's the Django ORM. It's included in the Django Web Development Framework. Remember, we said that Django is a full stack framework. It includes the ORM. There is SQL Alchemy, and that's the one we'll use with our web app today. There's also SQL Object and Storm and Triton. So we'll use SQL Alchemy for our ORM. This will allow us to access and manipulate data in the database as Python objects. But we have one more choice to make. Which database do we use? SQL Alchemy supports several database engines. We'll choose SQLite. SQLite provides a lightweight, disk-based database. It's convenient and easy to use because it does not require a separate server. Some applications actually use SQLite to store application data. SQL Alchemy may be used with different web frameworks. Since we're using Flask, we'll use a version of SQL Alchemy that's specifically tailored for Flask. Flask SQL Alchemy handles session configuration, setup, and teardown for us, so it's a little simpler to use than the generic SQL Alchemy. Of course, we need to install it first. Let's do that next. We go to Preferences, click on Project Interpreter, click on the plus sign, and search for Flask-SQL Alchemy. And here it is. We click Install Package to install it. And we're done. We have a new skeleton module available on Canvas, Flask app db.py. This module adds database access to our Flask web app. If you are still running the Flask app server, make sure you stop it first. Then download Flask app db.py and save it in your PyCharm project folder. So here's our new module, Flask app DB. You can see that in addition to importing Flask request and render template, we are importing SQL Alchemy. Note that I have saved my module, Flask app DB, in the folder Demo Flask. The first thing we need to do is create the database, and we're going to do that from the Python console. We import the DB SQL Alchemy object from our Flask app DB module. Now my Flask app DB module is saved inside the demo Flask folder, so I write from demoflask.flaskappdb import db. Then I invoke the createAll method on the DB object to create all the columns in the database. And we can actually look here on the right and see that DB is an SQLite database, and its name is actually cs122.db. This name was set in the app config statement in Flask app DB. So it may take a while, but eventually in our demo Flask folder, we'll see the database cs122.db appear there. And here it is. Now let's see how the data in the database is mapped onto Python objects. The class review provides our model. It inherits from dp.model, and we can see that in our database we have a single table. Its name is review, and we have 3 columns. One column represents the review ID, and that's an integer, and that's the primary key. Another column is a string, that's the comment, that's the actual review. And the last column is the grade of the student who's writing the review. So now, instead of writing SQL statements to access and manipulate data in our database, we can simply write Python code to access and manipulate review objects. Let's take a look at the rest of our program. So we have the routes defined here. The home route is identical to what we had before. The about function is doing more than just rendering the template here. We'll come back to it a little later. We have a new review route and we have a new review function. So let's take a look at this function and see what's going on here. The function renders a review template. So let's take a look at the template in our template folder. Here is the review template. It includes a form element with a post method associated with it. Remember, the post method allows us to create new resources or update existing resources. Let's open review.html in the browser. And here's what we get. So this form allows the user to type in a comment and a grade received on CS122. And then once the user clicks on the submit button, that information is supposed to be sent to the server and saved in the database. Let's go back to the review function and see how that is achieved. So the first thing to note is that our route decorator here specifies 2 methods, post and get. So that means that this route is supposed to support both the post and the get method. If we don't specify the methods argument here, the default method supported is get. The review.html template is rendered in both cases, for the post method and for the get method. However, there's some extra work to be done for the post method. So when do we have a post method and when do we have a get method? We have a post method when the user clicks on the submit button of the HTML form. That's when the browser sends a post request to the server. Otherwise, if the user is just viewing the web pages without hitting submit, the browser sends a get request to the server. So when we receive a post request, we retrieve the specific fields from the request object. So here we retrieve the comment and the grade that were entered by the user. We save them in the variables comment input and grade input. And then we instantiate a new review object and specify the comment and the grade as arguments. So that's how we create a new row in our database table. We just instantiate an object and then we call the add method on db.session to add that new object to the database. And then we invoke the commit method on db session. And that's it. Now we have created a new row in the database. Now let's start our server and then open a browser window and enter some reviews. We need to add some rows to our database. So we'll make up some reviews. Enter a comment and a grade and then hit submit. So I have 4 reviews here. Let's go back to our about function and see what's going on. We have added a query. We are querying the database. And when we do that, we get a list of Python review objects. So results here is a Python list. We pass results as an argument to render template. Now all we need to do is modify our about.html template to list all these review objects on the web page. We'll use Jinja 2 for that.